So after that, I'm going to the fourth unit. Going to start the fourth unit. Okay. So this is also a very easy and you can easily understand the concepts. So once you know the concepts of diodes and currents, so it is easy to understand the fourth unit, that is corresponds to BJT. So BJT is nothing but a bipolar junction transistor. So transistor is a combination of three layers, whereas diode is a combination of two layers. PN, combination of PN, two layers. Okay. So coming to the bipolar junction transistor, we can simply call it as a BJT. As a short form, we can call it as a BJT. So it is having three layers. So those are called as a base emitter and collector. So we can call it as base emitter and collector. Okay. So we can operate this is in different configurations also. So the major application of this BJT is to amplify the signal. So the very weak signals will be present in the circuit, and those weak signals will be increases. It means the amplitude or the strength of this signal will be increases by using the BJT, by using the bipolar junction transistor. So the main application of BJT is to amplify the amplitude. So a small amplitude is applied to the base of the to get the magnitude output signal at the collector. So we can get the higher amplitude at the output side. So it is having input and output. Okay, bipolar junction is having input and output. The amplification in transistor is achieved by passing input current signal from a low region of low resistance to a region of high resistance. So that amplification is possible by providing low resistance region to high resistance region. And the concept of transfer for resistance is known as the transfer resistor. Okay, from the transfer resistor, trans and from the resistor IST, or by the combination of these two, the transistor was formed. The word was obtained from the transfer resistor. Okay, so it will be transfers the resistance from low resistance to high resistance. So that's why the name itself came as transistor. Transistor. Okay, transistor. So actually there are two types of transistors. So one is a UJT. You can call it as a unipolar junction transistor, and another one is bipolar junction transistor. Unipolar junction transistor and bipolar junction transistor. If you consider the unipolar means, uni means one direction only. Unipolar is one direction. So the conduction is based upon the only one type of the charge carriers in unipolar junction transistor. The current conduction is only due to one type of the carrier, whether either it is holes or current, holes or electrons. So if you consider the bipolar junction transistor, that is BJT, the current conduction in BJT is because of the two types of charge carriers. So that is holes and electrons. So the current will be possible with the two charge carriers, holes and electrons. Due to holes, we have the current. Due to electrons, we have the current. Due to two charge carriers, we have the current in BJT. Hence, it is called bipolar. Okay. So bipolar junction. So bipolar, both the charge carriers will take place the current. So that's why it is bipolar. Whereas unipolar means only single. Uni means it represents single, only one. Okay. So unipolar UJT, you can call it as UJT, and this is called as BJT. So we are going to study about the BJT, bipolar junction transistor. So again, the BJTs are two types. So bipolar junction transistors are again two types. One is a NPN type transistor and PNP type transistor. So NPN type transistor. So we are previously seen that diode is a combination of P and N type of materials. P type semiconductor material and N type semiconductor materials. These two will be joined. So okay, with that we can get the PN junction diode. So whereas for the BJTs, that is transistors, bipolar junction transistors, we can have NPN type transistor and PNP type transistor. So here NPN. So it represents the type of materials which are connected, which are joined. So if you consider three, if you sandwich the P type material on both sides with the N type material. So just like our uh, bread slice bread sandwich. So we take one piece of one bread, and other side we can take another type of the bread, and we can join that. We can get a combination of bread slices. So like that. So there is a P type and N type materials are will be taken, and from that we will join join the this P and N type materials. So take the P type material for construction of the NPN transistor. Take the P type material on both sides of this P type material. You can attach the N type material. Okay. So the formation of this NPN and PNP is based upon two types of methods will be there. So one is alloying method, and another one is the diffusion method. So by using this alloying method and diffusion methods, they will construct the transistors. So depending upon that methods, we can alloying and diffusion. Okay. So based upon these two methods, these transistors will be constructed. Okay. So for coming to the PNP transistor, so considering the N-type material, and for that N-type material, both sides of N-type material, we will attach the P-type material by using the alloying method or diffusion method. Okay, and below these figures, you may observe the symbols. Okay, so you can write these symbols as so this is the, you can write like this transistor symbol. Okay, so equal distance here should maintain here. Okay, so this is the, so we can represent one arrow here. Okay, so the arrow indicates arrow terminal. It is having three terminals. Transistor is having three terminals. So arrow terminal indicates the emitter. It will represented as E. This terminal is represented as the base B, and this terminal represented as collector C. Okay, so like this, this is called as NPN transistor. For NPN transistor, the arrow is outside of the, this will be represented in a circle. Okay, so for NPN transistor, the arrow is outside of the circle. Okay, so whereas PNP transistor, the arrow is at base region. This is the base region. So the arrow connected terminal is the emitter. The terminal which is connected this point is called as base, and this is the collector. Another terminal is the collector. Okay, for PNP transistor, the arrow is inside. For NPN transistor, the arrow is outside. You should remember this difference. The circuit representation for NPN transistor, the arrow is outside of the, that arrow is at emitter terminal only. That arrow is at for the emitter terminal. So here we have emitter, base, and collector. Okay, so what is this emitter, base, and collector? So if you have the construction of the PNP transistor is based upon the doping. So what we can call doping? Doping is adding impurity impurity atoms to the pure semiconductors. So doping. So here, if you consider N-type semiconductor material, so it is heavily doped. It is heavily doped. It means more amount of impurities will be doped in the pure semiconductors. Okay, so that's why the concentration of the more electrons will be available at N type. Okay, so when compared to emitter P type material, this is a P type material. P type material is lightly doped, and whereas N type material on the collector, this one is collector. So this collector is moderately doped. So it is in between the emitter and base. So we can we can dope the material, impurity material to the pure semiconductor in such a way that the impurity materials are in between the both the emitter and base. Whereas p-type material, that is the base region, this is the base region. This base region, the doping is lightly doped, whereas the emitter region is, it is heavily doped, heavily doped. So here you can observe this, the width of the emitter is more than the p region, and p region width is very small. P region width is very small. So you can, so just by the diagram representation it is represented like this, but actually it is so the base region is very thin region. The width is very small. This is the base region, and so this is the B, that is base region, and this is the emitter region, and this is the collector region. So the width of the base region is very small when compared to emitter and collector. The width of the emitter is small when compared to collector. So the collector region is, the width of the collector region is more than the emitter region. The width of the emitter region is more than the base region. So the base region is very thin. Okay, the base region is very thin. So in such a way that the construction of the transistors will be takes place. Even the diagrammatically it is represented as equal space in the figure, in this figure. In this figure, almost same, but the collector region, this is the collector region, it is having large width when compared to emitter, but base region is very thin when compared to both the emitter and collector. So this P region is called as emitter. This is and another P side is called as collector, and in between we have N is the base region. Okay, so like this we have construction of the transistors, PNP and NPN transistor. Okay, by considering the P-type and N-type materials. So here, one more thing. So you can consider NPN transistor is a back-to-back connection of two diodes. Back-to-back connection of two diodes. So this is NPN transistor. This is one diode and this is the another diode. When these two diodes are connected in back to back, it is formed as a NPN transistor. But practically, when you connect the practically if you connect the two diodes in such a manner, it does not work as an transistor. Okay, it does not work as an transistor when two diodes are connected like this. Practically, so but it is, the transistor is similar, acts as a two diodes are connected back to back. So it is called as analogy. It is similar way, but really if you connect two diodes in such a way that it does not work as a transistor. Okay, so like this we have PNP transistor. So most of the cases we can discuss about NPN transistor. Okay, so because it is easy to understand, and if you consider the transistor action. So here it is unbiased transistor. So this there is no external voltage is applied. So how this transistor will be having? I mean, so PNP and base collector emitter regions, how they will be formed. So similarly, here N and P type and N type materials are joined together. So the region between emitter and base is called as emitter base junction. Okay, so due to that, this combination, there is a formation of depletion region. When we join the base region P and the collector region N, so there is a one junction will be formed between these two. Base and collector will form another junction. So that is collector base junction. We can call it as collector base junction. So due to this, there is a depletion layer will be formed between the base and collector. Okay, there are two junctions in the transistors. Wait. Hello? Hello?
Yes, sir.
Okay. So here we can observe that. So the base and emitter and base junction, there is a junction will be formed. Okay, due to that the depletion region. And similarly, collector and base, so there is junction will be formed. That is due to um, PN junction. Okay, so the right side of the figure shows the we have considered the N. These are the electrons. These are the electrons, and on the base side we have formed a depletion region. Okay, so these are the positive charge carriers. Plus sign indicates the positive charge carriers, and negative sign indicates the electrons, that is negative charge carriers. Okay, so this is the base region, and in between base and emitter we have a depletion region. So here, so the depletion width will be changes depending upon the doping. Okay, the width will be increases more in the less doped, lightly doped. Okay, if we consider this region, this is the junction. Okay, on the emitter side, this width is very small when compared to base side. Okay, so the width of the base side is very more than the width on the emitter side, because emitter is highly doped. Okay, so that's why more amount of electrons if it tries to diffuse into the base region, because base side is lightly doped. So that's why more amount of electrons will try to occupy this base region, and less number of holes will be tried to occupy on the emitter region. So that's why this will be formed as a positive and negative charge carriers at this point. Okay, and coming to base and collector, so collector is moderately doped and base is lightly doped. Okay, so that's why more amount of diffusion will takes place on the base side, because this width is when compared to emitter side, this width is very high, because the collector is the width of the collector is higher than the emitter side. The width of the collector is higher than the emitter. So like this, there is a junctions will be formed at the emitter base and collector base junctions. Okay, so this is unbiased transistor. So for the proper functioning of the transistor, we have to connect the voltage. So that is called as biasing. Okay, so when the emitter base junction is connected forward biased and the collector base junction is connected as reverse biased, then it will be called as active region. The transistor will be works in the active region. So most of the cases, the transistor will be works on the active region only. Okay, so if we consider this is the NPN, so always remember that always emitter and base should be forward biased, and the collector and base should be reverse biased. So when we can say it is forward biased, the terminal of the positive terminal is connected to P side and the negative terminal is connected to the N side. Then we can call it as a forward bias. If we connect it is reverse, that is the P side of the battery is connected to N side, and negative terminal is connected to P side, then it is reverse bias. If we consider this NPN transistor, so here this is the emitter NPN. N is the emitter, P is the base, C is the N is the collector. So N emitter and base always should be connected in forward bias. Here because this is the N, so N is nothing but negative. So the battery of the terminal should be connected to the negative terminal, and other terminal is with respect to base. So base is connected to positive. Okay, base is connected to positive. Coming to collector and base, collector here it is a positive. Okay, so but collector and base junction always reverse bias. Collector and base junction is always reverse bias. That's why negative of this collector is connected to positive terminal. Collector of the this n terminal is connected to positive terminal, and the negative of the battery is connected to the positive terminal. So then this is a reverse bias. Okay, so emitter and base is forward bias, and a collector and base region is always reverse bias. Then only we can call it as the transistor is operating in the active region. Active region. So if suppose we are connected emitter base junction, emitter base junction, this is the emitter base junction. Okay, emitter base junction is reverse biased, and a collector base junction is also reverse biased. If the collector base junction is also reverse biased, then we can call it as a cutoff region of operation. Similarly, when the emitter and base junction is forward biased and the collector and base junctions are reverse biased, then we can call it as a operated saturation region. So the operation of this particular regions will be represented in a graph sheet. Okay, so the region, this is the region. Okay, this is the region. This is the collector current and collector to emitter voltage. Collector to emitter voltage. So if you observe this, this is the saturation region. Okay, so this saturation region is happens when both the saturation region is obtained when the emitter base junction is forward bias and the collector base junction is forward bias. Both the junctions are connected in forward bias, and this is the region of active region. Up to here, this is the active region, and below side we have dotted line, mark line is there. Okay, so up to this point it will be called as cutoff region. Up to this point it is called as cutoff region. So when the cutoff region operation is happens when both the junctions, emitter base and collector base junctions, both will be reverse biased. So in such situation, the transistor will operate in the cutoff region. But proper output and proper action of the transistor should be operated in active region. So active region is nothing but the emitter base junction is forward bias and the collector base junction is reverse bias. Like this we can connect, then only it will be operated in the proper amplification. We can get the proper amplification. So when it is operated in saturation region and the cutoff region, what happens? The sum of the signal will be cut off. Okay, when the input signal we are applied, a sinusoidal signal we are applied, the input sinusoidal signal is applied as the input for the transistor. Okay, for transistor we are applied. Okay, so at the output, some sort of the output will be cut off will be happens. So actually this is the so this some part of the portion, this is some part of the portion will be cut off will be takes place. That's why this transistor output is not same as the input. But as the transistor main function is to increase the amplitude. But the shape of the input signal should be same. The shape of the input signal remains the same, does not change as the input. Okay, so when the transistor is operated in saturation region, cutoff region, there is a some cutoff of the signal will be takes place. Some loss of the signal will be takes place. That's why the transistor never operated in saturation region and the cutoff region. It should be operated in active region only. Okay. So this is the different regions of the transistor we can operate the but the proper output should be obtained in the active region only. So when the working of the PNP NPN transistor, so when we connect the voltages across the NPN transistor, how the current will be flows, how it will be works. Okay, so that we'll see. So we told that So the emitter region and base region always forward bias. Here N is the N is negative. So the battery of the negative terminal is connected to emitter. N is the emitter and base region is positive. So this is the forward bias. And coming to collector side, the collector is N. So N is connected to positive side of the battery. So then this is the reverse bias. So in such situation, how the how the transistor will be operates or works. Okay, so that we'll see. This is the just condition. So this is the base emitter depletion region and this is the collector base depletion region. So the width of the collector base depletion region is more than the width of the base emitter region. So generally what happens when we apply the voltage across this base and emitter base, what happens in the n-type material, the majority charge carriers are electrons. So the battery side is considered as negative. So this is also negative, and on the negative side, the negative will be repulse. That's why the electrons will be crosses this junction, this depletion region, and moves to the base region. So in the base region, the majority carriers are holes. On the base region, the majority charge carriers are holes, and these electrons will be recombined in the P region. But the P region is lightly doped. Okay, there are less number of holes will be present. So that's why, whereas emitter is heavily doped, that's why more number of electrons will be present here. So that more number of electrons will be try to cross this base region. Okay, so see here, this is the in the P region. In the P region, majority charge carriers are holes, whereas N region majority charge carriers are electrons. This when we apply the negative side to the N side, that is due to repulsion force of these electrons. Okay, these electrons in the N region, more number of electrons will try to cross this junction and move comes into the P region. Whereas P region we have holes, but there is less number of holes, and that's why less number of electrons and holes combination will be takes place. Suppose 100 number of electrons will be coming towards the base region, whereas here we have 2 number of holes will be present. Then what happens? 100 in the out of 100 electrons, 2 electrons will be recombined in the holes. Okay, and remaining 98 electrons are there, and those 98 electrons will be moves towards the collector. Because here on the collector side we have a positive potential. On the collector side we have positive potential. When this positive potential will attract the number of electrons which are coming towards this one collector. So that's why more number of electrons will be coming to collector, and those more number of due to that more number of electrons will be travels through this. There is a current will be takes place. Okay, here a small amount of the small amount of current will be amplified and it will be collected as the higher value as the output. So if you observe this, when the 2 electrons are combined with the holes in the P region, so due to that we have a small amount of the current will be takes place. That is called a base current. The current which is between the emitter and base is the called as base current, that is IB. And due to this the current due to the electrons which will take place, that is called as a emitter current. And here the more number of electrons will be crosses this P junction and enters into the collector region. So whereas in the collector region, again this depletion region will be decreases. More number of electrons will try to cross this collector region, and they will be trying to reach the positive terminal, are attracted by these electrons, and that's why the electrons will be tries to attract this positive terminal. Due to that we have the current. Okay, so and that current will be called as collector current. That current is called as collector current. So if you observe these figures, so when electron flow across emitter base junction, so due to the electrons, see here electrons are represented by dotted lines and holes are represented by small holes. Okay, so in the PN junction diode or transistor, the dotted line indicates the electron and hole will indicate the positive charge carrier. Okay, so small hole is a hole. Okay, so in the NPN transistor, if you connect the base and emitter forward bias, so more number of electrons are present in the emitter region, and these electrons will try to cross this depletion region and enters into the base region. So whereas base region, less number of holes will be there. That's why hole electron combination is the electrons will fill these holes, and due to that the current will be there. So that is called as base electron current IB. And more number of electrons will try to cross the base and collector region and junction, base and collector junction. And due to that, more number of electrons will comes to the collector. This is shown in the next figure. So the more number of electrons will try to attract the positive potential, and due to that we have the current of IC, collector electron current, that is IC. So here, so that is the operation of the NPN transistor, and similarly we have a PNP transistor. So in the PNP transistor, the combination of P and P. So here the P is the emitter and N is the base, and another side of P is the collector. So these are also same. Emitter is heavily doped, base region is lightly doped, and collector region is moderately doped. Okay, so when these are combined, there is a depletion regions are formed between the two junctions, two regions. So emitter and base region will form as a one depletion region, and collector and base region will form a one depletion region. When we connect the forward bias, okay, P type and N type, we will connect the forward bias. Forward bias means here this is the P side, and P side is connected to positive terminal of the voltage source. P side is connected to positive terminal of the voltage source, and B side it is negative. And whereas collector it is reverse bias, always reverse bias. That's all. Remember that emitter and base junction is forward bias, and the collector and base bias is always reverse bias. So P side is connected to negative. Okay, positive is connected to P side of the is collector is connected to negative. Then it is reverse bias. Okay, so and another term is automatically it is positive. So when we are connected to PNP transistor with these sources, so what happens on the P side? The more number of charge carriers are the holes. See here, these are holes are represented as small holes. Okay, so you are applied positive terminal at here. So the positive and positive terminals, these are holes are positive charge carriers, and positive will reflect, and due to that more number of holes will be try to cross this depletion region and enters into the base region. Okay, depletion layer crosses the depletion layer and enters the base region. Whereas in the base region, the N is the it is having majority charge carriers are electrons, but it is lightly doped. That's why a small number of electrons will be recombined with the holes, and due to that we have a current of IB current. Okay, and remaining holes, if you assume that 100 holes are coming towards this base region, some of the holes, that is 2 holes, will be recombined with the electrons, and due to that we have a small amount of base current will be obtained, and remaining 98 holes will be crosses this base region and enters into the collector region. So in the collector region, what happens? The more here, this is the positive negative terminal. So negative terminal will attract the positive charge carriers, and due to that, there is a large amount of current will flows through this circuit. So there is a large amount of holes will be attracted. Okay, and due to that, we have a higher amount of current will flows at the output side. So this is the input side, and this is the output side. You can observe. Okay, this is the uh, collector hole current. So the more number of holes will be crosses this depletion region between base and the collector and enters into the collector region, and the more the holes will be attracted by this positive negative terminal, and due to that we have a collector current IC. So generally IE. So this is the source of the current is IE. So if you consider for the this is the N type, so this is the IE. IE is the current due to the emitter and base. Similarly, IC is the current due to collector and base. IC. So generally we have IE is equals to IB plus IC. So these are the transistor currents. IE is equals to IB plus IC. So IB is almost small when compared to IC. So that's why IE is equals to IC. IE is equals to IC. So there is less than 1 minute is there. Okay. So there is ICBO, reverse saturation current when the emitter is open. So when the emitter is open there is the reverse current is also present. So that reverse saturation current is called as ICBO. ICBO. Okay. So transistors are connected in three configurations: common base configuration, common emitter configuration, and common collector configuration. So we have three terminals. If you consider base is common for the input and output, then it is common base configuration. If you consider emitter is the common for the input and output, then it is common emitter configuration. If you